I started this recording, and let's start. And like this is the sort of agenda of our course. So far we have completed this introduction part of SDXS and DNA Center. Now we are at this third point, solution component, right? SDXS solution component. So today we'll try to finish this, and the next lecture we are going to discuss the wireless architecture. Right. After completing this particular session, you will be familiarized with LISP, VXLAN, Cisco TrustSec, and how to integrate Cisco ISE to DNA Center. Like what are the prerequisites, what would be the flow and all. So that is the overall agenda for this particular lecture. So, right, like we earlier we discussed this control data and policy plane, and we have known about this terminology, like LISP is used for control plane, VXLAN would be used for data plane, and TrustSec would be used in this policy plane. And in SDXS, these are the three main component or operational planes, I would say, on which the entire SDXS architecture has established. Now, if you see some of the terminology which we need to be familiar before proceeding further, because when you troubleshoot, when you try to get into the CLI and try to identify each and everything, you must come across with this terminology. And some of the terminology are very common, I would say. Suppose if you work on VXLAN before, so you must have known this VTAP or DTAP, DVTAP, right? So SVTAP means source virtual tunnel endpoint, and DVTAP means destination virtual tunnel endpoint. So those are the terminology which we need to consider, because in SDXS, whenever you are doing any sort of things, you must have some sort of knowledge on this terminology. And this terminology have been inherited from the protocol itself. Like on LISP, we are using MSMR. When I talk about LISP, so LISP is different protocol, which is location identity separation protocol, locator identity separation protocol, right? That is the full form of that. But when we talk about LISP alone without SDA, so some of the terminology are different. Because in LISP, we are using MS, which is your map server, map responder, which is MSMR, where in SDXS fabric, the same MSMR will be known as control plane, right? So the control plane is the one device who actually perform these two functionality, which is your map server and map register. That's why we called in SDXS in different way. So this terminology are as per the SDXS fabric. So you keep in mind that ITR, ETR, XTR, PITR, PETR, PXTR. So when I say ITR, that is your ingress tunnel router. The first one is under LISP, right? So we will discuss that much more in detail. What is ingress tunnel? What is egress tunnel? What is XTR, right? But on high level, you can just go through with this and have some sort of image in your mind that, okay, we are going to learn this in upcoming slides. Okay. Now, here, see in fabric side, we have a couple of things like sets of control planes, border, and edge node. Then the fabric domain would be list of couple of fabric site, or it's a single site. So based on the deployment, based on the size of the network, you can define your fabric domain. So in one domain, you can have a couple of fabric sites, or else if a customer has standalone deployment and has small setup, then it could be a single fabric site in one fabric domain, right? Then virtual network. So virtual network stands for VRF. So whatever we know about VRF, the same concept we are using here is a virtual network. So in SDXS fabric, we are generally discussing all the terminology related to VF, not VRF. So you may not heard anything about VRF, always heard about VM. And that is the LISP instance. So when I talk about, I have two VRF, VRF A and VRF B. So in the background, in the control plane, I would having two different Lisp instance. So that is the VRF itself. So whatever, like if you heard Lisp instance or VN, these two terminology tie with this VRF term. For scalable group, yeah, you must have known, because based on our last lecture, I have discussed that scalable group is just identity container. It carries the identity of the endpoint, whether that endpoint is particular user or camera or badge reader or any of the device, right? Or IoT device. So that is the identity container. So here we are using SGT, but generally in VXLAN term, it calls as a segment or group. 1 second, my slide got changed. Okay. For host pool, so we are using a couple of IP address pool for overlay and underlay. And generally, our point-to-point connectivity will be used with the underlay IP address. But when we talk about SDXS fabric, everything is overlay. And that is the part of the IP address assignment when you are creating and reserving the host pool. So whatever the host pool which you have, that is based on the IP address. And when the IP address gets assigned to specific user, it is based on the authentication and the VLAN assignment, right? So that is the kind of terminology you can remember. So this, whatever the terminology mentioned here, you can see and have some look. Any questions so far, guys? Are we good? Okay, now answer means everything is good. So as I told you, right, like upon completing this particular section, you should have the knowledge of different types of protocol which are used in SDXS fabric. And we will discuss a couple of things around the integration process between Cisco DNA Center and Cisco ICE. So let's start actually. So we'll start with the control plane. So control plane has this type of database, which is known as host tracking database. And in Lisp, this particular control plane node is known as a map server, map resolver, because it actually gets the query from different edge switches, and it will try to solve that particular query, and it will give the reply. And that reply would be map response message, right? In Lisp terminology. But in SDXS, the entire component, entire device is known as control plane, which actually do both the thing, like map server and map resolver, both the thing. Like it will take the query and it will also resolve the query. The same like DNS, right? So whenever any DNS hits any query from the device, that what is the IP address of this particular name, it will try to look into its database and give the response back. Otherwise, if it doesn't have the response, then it will give the two types of query, right? In DNS, generally recursive and iterative. So same like that, similar kind of concept which Lisp is using or having, I would say. And the first thing is control plane has this type of host tracking database. We'll see how it looks like, what is the table and what types of mapping it has. So you can see a simple host database, which we just discussed. It has.
1 minute. Do my setting first.
Guys, anyone has any question? Okay.
I think Samarth is trying to talk on that time.
All right. Okay. No question, right? Okay. So host tracking database supports multiple types of endpoints, like whether your endpoint would be IPv4, IPv6, MAC, or some of the dumb device. And so when I say some of the dumb device, that means some of the IoT device which generally don't active, but whenever it has some data or whenever it has some information to send to server, like any sensor, it will just get the powered on, and based on the request, it will forward data. So endpoint could be anything, but host tracking database has always have the entry of that particular endpoint, right? If it does not have the entry, it will give the negative reply to the querier who is querying the particular request. So we discussed that as well, like it receives the IP endpoint IP or ID map registration from the edge switch. or the border nodes. So based on the traffic, like wherever the endpoint has connected, it will try to first register itself to the control plane. And once again, I'm just trying to get this highlight. Yeah, okay, laser pointer. So it will try to register the particular endpoint on the database itself, where from which edge node it has connected to, and based on that, it will create a local entry on the host tracking database. So yeah, based on the request, it will resolve the lookup, like whatever the terminology which we used in LISP actual deployment map resolver, the same thing it do as a control plane. Now, before this, like before LISP, how we used to configure the routing, you know already, right? Like we have different types of routing table, and all the routing tables are like push-based mechanism. So each and every router will push the update to the other router, and all the router has having the identical routing table or database mostly. And each and every router has to manage their data, routing information base and forwarding information base, right? So it gives so many problems, like we have big IP tables, big routing tables, more CPU intensive, because whenever any packet hits to the interface, it needs to be processed by CPU, right? Whenever any routing decision needs to be made. And every time if you have big routing tables, then it takes time. But nowadays, like with this new advanced ASICs and everything, it is normal. But the thing is, like we are trying to optimize more. So in terms of optimization, LISP is the best protocol which we identify to implement in SDXS fabric. That's why in LISP, if you can see here, so endpoints has actually consolidated on the host tracking database. So only router, wherever the router has any endpoint, it has the local entry in its map cache. So there is a specific cache memory of router, and on that cache memory, it has the specific entry for the connected endpoints, connected laptops, or connected any device, right? And whenever any endpoint gets connected initially, it will register to the control plane that, hey, I have one endpoint behind my loopback. So there is a kind of entry which has in the host tracking database. You can see the prefix and rlock. So rlock means the loopback IP address of the fabric edge device. So that is the thing. So here in LISP, we have small tables, and it is very less CPU intensive, I would say. And whenever we want to do any sort of roaming, the main use case is that actually. So that is a kind of anycast gateway concept. So any user wants to move or roam from one building to other building. So we don't need to do any sort of manual configuration on that gateway, that this is the gateway for this particular device, right? Or we don't need to do any sort of manual changes on the policy side. So with the help of anycast gateway, with the help of overlay architecture, we can achieve that very seamlessly, whether that user is wired or wireless. Irrespective of user type, we can have the seamless connectivity across the fabric. Okay, that slide has come again. Okay, always. So how LISP works? So you can see in SDXS solution, which involves multiple protocols. So in Cisco DNA Center, you know, it is the single pane of glass for deployment, like to configure anything, to monitor anything on your network infrastructure. And Cisco ISE, we have Cisco ISE is another component which makes this particular SDXS fabric unique, because it gives the policy and segmentation use case specifically for all the endpoints. So here in this particular fabric architecture, it uses multiple protocols within the overlay network to implement the segmentation and also provide routing and data plane encapsulation of the endpoint traffic. So LISP is used as a control plane, you know, and VXLAN would be used as a data plane. And Cisco Trust Seg would be used for policy plane. So here you can see on this topology, we have two endpoints. Endpoint one Here the EID is 10.1.1.11. That is the IP address of this particular laptop, the endpoint one, right? The MAC address. And suppose if this endpoint has the IPv6 address, then you can consider the third one IP for IPv6. Same here, we have endpoint 2, the IP address, which is 1.12. Both are in the same subnet. The MAC address is different, and the IPv6 address. Now, when I say RLOC address, right, here you can see RLOC, which is your remote location. And when we are using LISP, we are actually segregating or separating the identity of the user of the endpoint to the RLOC, which is your remote location. So remote location would be anything like this fabric edge one or this fabric edge one, whoever would be the part in fabric consider as a it should have the RLOC address. And mostly in SDXS, RLOC address would be the loopback 0 address, which is the reachable IP address internally. Like this loopback should be reachable to this fabric edge 2 loopback, right? So whenever this device gets connected to this fabric edge, after authentication authorization, this device gets assigned to specific virtual network and specific tag, which is the identity container, whether this user is contractor or whether this user is the normal employee or whether this user is a HR. Based on the criteria or based on the authentication and authorization policy, which you have defined already in ICE, it gets this type of tagging, and it will try the fabric edge will register this user endpoint 1 to the control plane that, hey, I have one user. The IP address of that user is 10.1.1.11, and it is connected behind me. So when it says that it is connected behind me, that means it gives its own RLOC address, which is 1.1.1.1, right? So we'll see how that table has created and what could be the packet flow in this sense. Now,
Sir,
I hope
excuse me.
Yeah.
Can you go back to that previous slide?
Sure.
Okay. Here the RLOC, the IP address that we are talking about, is it like the IP address of the device, the networking device where the endpoint is connected to, kind of like the same IP address through which we access the device as network admins, or it's something else?
Yeah, so this particular RLOC address would be the overlay IP address. And when I say overlay IP address, so once you have all the fabric edge node or all the device, like even the border node has the loopback 0, right? Even control plane has the loopback 0. So any device in the fabric who is having loopback 0, we are consider that particular IP address as the remote location IP address, because loopback would be different for all the device. Loopback will never be same. And based on the loopback itself, we can identify that this particular fabric edge is placed on this particular building. This particular fabric edge too is placed on the different building or different floor or different location, right?
So this IP is not necessarily the management IP of the device, right?
It is not necessarily, but most of the time we are using that type of concept where you can manage your device with this loopback as well. But based on design, it's totally based on the design and customer requirement, because most of the time customers have different management VLAN, which generally is not VLAN 1. By default on all Cisco switches, we have VLAN 1. But in production, if you go and see, then the management VLAN would be different, right? So you can have different type of options when you are deploying, but yeah, you can manage the device with this RLOC IP address as well once you have the reachability.
Okay, thanks, sir.
Okay. Now let's dig deep into the actual terminology in case if someone has not understand the concept, why we are using this separation, why we want to have this identity separated from the location. So if you consider our mobile network, right? So we have our phone number, which is mentioned here, you can see, and we have our tower location from where we are getting the signals. So when any user insert its SIM card and start its phone, right? Your phone will start getting the signals from the nearest service provider tower, and that location would be the fix. So for area specific, there is a location. Now, if you see that user, the same user is going from one location to other location, the number would remain same, but the location of the tower from where it is getting the signal, where he is getting the signal, it has changed. So here it was San Jose, here it is New York. So based on that, we can identify, okay, now user has moved from this building to this building. Same like this particular scenario, which we are using in our daily life, right? So this is quite simple as this. So the mobility is the main use case for LISP to use, and the computation and the memory, that is another add-on advantage when we are talking about LISP. Now, here, if you can see, I discussed that host tracking database, right? So here there is a kind of mapping which the table has. So you can see I have one IP address 10.1.1.11 from the previous slide, right? 10.1.1.11 and 10.1.1.12. And the RLOC address you also remember 1.1.1.1 and 1.1.1.2. The same mapping has done that 10.1.1.1 behind edge 1 and 10.1.1.12 is behind edge 2. And when I say edge 1 and edge 2, it would be the IP address, RLOC IP address of the specific edge, the loopback IP address, right? Here, to make you understand more clear, that's why I have changed to edge 1 and edge 2, but otherwise it should be the IP address. It has the MAC address of both the devices, and the ARP resolution table as well. And the interesting part is the ARP, how ARP resolves here in SDXS Fabric is quite unique to understand. So I have created one kind of traffic flow, which gives you the overall idea, like how my ARP is getting resolved and how all the entries are being created on the database table, host tracking database. Now let's talk about some of the points on data plane. So we are using VXLAN. Why we are using VXLAN? That is also an important point to know, because VXLAN has some of the functionality which will be used to carry the identity of the endpoints from one fabric edge to other fabric edge. And VXLAN would be using this kind of tunneled architecture. Everything is tunnel, but again, like on VXLAN side, we are again encapsulating and adding the new IP header, right? So whenever any fabric edge is trying to connect to this particular this particular endpoint 2, like suppose this endpoint 1 is trying to connect to endpoint 2, it always sends the packet to this fabric edge. Fabric edge 1 has the local map cache entry. In that map cache entry, suppose it has already information about the endpoint 2 where it has connected, then it will try to create the VXLAN tunnel. It will try to initiate the VXLAN tunnel from this RLOC to this RLOC. So RLOC from 1111 and the destination IP address would be 1112, the loopback IP address. This tunnel, VXLAN tunnel, will be created on loopback to loopback from different fabric edges based on the traffic flow. And some of the thing like LISP generally works on the layer 3 overlay, right? But VXLAN can be used for layer 2 and layer 3 as well, because when we are resolving the MAC address, we are using ARP as well. So that's why we are using layer 2 as well as layer 3 on overlay. And some of the broadcast traffic. So in SDXS, like many of the customer is using broadcast or layer 2 flooding type of concepts, where some of the endpoints needs to be connected in a broadcast way or layer 2 broadcast way or multicast way, right? So in that type of scenario, VXLAN will be used for to carry that type of traffic. Now for policy, ICE is the critical component, and without ICE, we can't use this Cisco Trust Stack or any of the policy related feature. And ICE integration is really important with DNAC because based on that integration, it will try to give and push all the config to the specific switches and assign the particular endpoint to the specific identity container, which is your SGT. And that SGT would be very important. I mean, it's really important when you are forwarding the traffic, the data traffic. So traffic decision will take this SGT, and I mean, any of the traffic decision will be made based on the SGT permission, right? Like this SGT, SGT1 and SGT2, whether these two SGT, the permission has allowed or not. So based on that, traffic decision will be made.
What is the full form of SGT, sir?
Scalable group tags.
Okay, thanks.
So let's dig deep into the Lisp operation. So this is the time to go deep and see the packet flow. Okay. Any doubt if you have, feel free to ask me. But this is really simple. Once you go with the flow, you can understand very easily. Now, we discussed that EID, right? Endpoint identifier. That is the specific IP or host address, which will be used for the endpoints or any machines. Quite simple. RLOC would be the routing locator. That is the IP address, loopback IP address of any device who will be the part of the fabric. So here you can see we have RLOC space. That means this particular cloud you can see in the background is the fabric, and all of my loopback 0 is reachable to each other. So that is my RLOC space. EID space would be here only. You can see any device connected to the fabric edge node, access nodes, that particular space will be known as EID space. So we are actually separating these two spaces, right? Now, map system. So this is quite generic, typical Lisp terminology, but in SDXS, we are not using this map system. But if you look any of the RFC or if you learn Lisp protocol by your own, you can understand that map system is the terminology which will be used in Lisp. The ITR and PXTR, these two terms are very important. So ITR means ingress tunnel router and PXTR means proxy tunnel router. What is the need to have these two different terminology and what purpose it solves? We will discuss that in further slides, right? But you can keep in mind, these are the initial terminology. And as I have already told, that EID to RLOC mapping has the specific table, which is host tracking database. The same thing it is mentioned here, EID to RLOC mapping. So when I say EID, that means the IP address of any device. And when I say RLOC, that means the loopback address of any of the fabric edge device, right? Okay, so this we have discussed already. Ingress and egress, we will discuss in upcoming slide, and proxy. So on high level, I would say, when I say ingress tunnel route, traffic, whenever the traffic is initiated, like suppose here you can see the user is sitting here and user is generating some traffic. So the first hop router, for that router, it will do the encapsulation, right? That router is known as the ingress tunnel router, because from this particular router or this particular fabric edge, it will initiate the VXLAN tunnel to the far end router or far end fabric edge. So based on the traffic flow, we have categorized the terminology. So
this is not, sorry to interrupt, this is not a typical WAN terminology that ingress and egress is like on the WAN end, where egress is the interface through which the traffic is getting out, and ingress is interface.
It is very typical and similar like that only.
Absolutely. So this is, in this case, when you say ingress tunnel router, that means the router which is initiating the tunnel.
Correct. So that is the point to catch, because whenever any user has connected, the router or fabric edge device is trying to initiate the VXLAN tunnel. So from that flow perspective, that device would be the ITR, which is ingress tunnel router.
Understood.
And ETR would be the egress whenever the traffic is coming. So here, these two devices would be known as the ETR because here the traffic or tunnel has been terminated, right? So that is the quite simple as that. PXTR is unique thing, which is the proxy tunnel router. So whenever, so generally, when we talk about the traditional LISP deployment, in traditional LISP deployment and the first version of LISP, it has not having this type of terminology of proxy tunnel router. It has these two terminology first, like ITR and ETR. But after some of the enhancement comes and it got introduced with this PXTR. So what happens is like whenever any user wants to send the traffic to the far end, right? So it will try to hit to the fabric edge router, fabric edge device. The fabric edge should has the entry. If it does not have the entry, it will try to reach to the control plane asking for that entry that, hey, I want to reach 10.2.2.2. Please give me the RLOC address of the 10.1.1.2. So either your map system in LISP can provide the reply, positive reply or negative reply based on the availability or based on the data, whatever it has in the host tracking database. If this device has not the information, like where my endpoint 10.1.1.2 has connected behind which RLOC, then it gives the negative map reply, and it will try to query, it will give the negative map reply, right? So that packet will drop. But here, what happens? We have one entry on any of the fabric edge in SDXS, which is the PXTR entry. That means if any of the time, any time your map server or control plane node gives you the negative map response that I don't have the entry, then this particular device, this fabric edge node, this ITR will try to query to the PXTR node. So PXTR node would be the proxy tunnel router, and that is the border node of your device in fabric. So border node, initially we discussed that border has two flavors, whether it is internal or external, or one flavor is like border is serving both these two options, like internal as well as external. So suppose user wants to reach to internet, right? And this internet route, Google route, 8.8.8 route, the mapping system or control plane has not in its host tracking database. So it will give the negative reply. Negative reply come on this ITR. Based on the negative reply, it will hit the PXTR, because whenever here on the LISP configuration, it has the type of configuration enabled. Whenever any negative response comes, use the proxy tunnel router. That is the gateway of last resort. So send your all traffic to PXTR. PXTR will take care of it. So it will forward the traffic to PXTR. PXTR should have the entry. If it does not have the entry, it will forward to the internet with the default route, right? So that's how the internet communication works, but we will discuss that much more in detail. But I just wanted to know the meaning of PXTR, because it will do the proxy of your device, right? Proxy tunnel router. That's why we are just calling as a PXTR.
Why am I getting a feel of DMVPN over here?
Sorry?
Why am I getting a feel of DMVPN infrastructure? This is much similar to DMVPN. Right.
I would say, but like here, LISP architecture is completely different to
Than DMVPN.
Yeah, the flow, the traffic, because it is.
No, other than the proxy tunnel route, if you don't have a route to that particular EID space right at the bottom, you go to the map system, get the route, and then go to the EID space. Correct. So that it's much similar to DMVP. It's not DMVP.
Yeah, you can consider it like similar kind of terminology, because in networking most of the time any enhancement comes, right? It's based on past history or past protocol.
So basically, you're trying to say that if at all the map system does not have the route to that EID space, then it goes to proxy tunnel route. Now, the proxy tunnel route is the main database, if that is the case.
No. don't consider that as a database because proxy tunnel router is the border router, and
Okay.
border would be the default gateway. It provides the gateway of last resort. So whenever you don't have anything as a next hop,
Okay.
come to proxy router will take care of it. Okay, so either proxy router has the default route towards internet, or
Okay.
proxy router has the data center connectivity and all the intranet prefixes are listed. The same
Oh.
thing happens here.
So even if in that case, even if ITR fails or ITR shuts down, we have proxy tunnel route to take care of the business.
So ITR is the fabric edge, and
Okay.
this particular fabric edge serves the endpoints only, right? Not any applications or not any not any servers has connected on the ITR, but it could be the chance where some of the servers are also connected on the ITR.
Okay.
But it is treated as an endpoint only, any
Understood.
endpoint.
Okay.
Yeah.
Understood. Thank you very much.
Sure. So now you can see this particular flow would be much more easy to understand. So here you have ETR, ITR, right? And I have one user behind this fabric edge. That's why it's known as ITR. And these are the destination or I would say my servers are located, or endpoints. Some of the endpoints are located, but that doesn't mean that this ITR is just ITR. It could be the ETR. Suppose my traffic is coming, or suppose my traffic is going from this particular fabric edge, right? But whenever any return traffic comes, then it will also act as a ETR. So ITR, ETR, both are the same, but based on the traffic flow, you can take the consideration. Now, here, any of the endpoints gets connected to fabric edge, the map register message goes to the control plane, right? And you can see all the loopbacks I have listed here. Those are the RLOC IP address. And on database, you can see this entry, the map cache has this entry at 10.2.0.0. That means this particular campus space. And I have two different fabric edge, right? Now, this user wants to reach to this particular IP address, 10.2.0.1, right? It will try to request to the map server. Map server request to this particular fabric edge that what is the IP address of the RLOC. So the control plane. So this is traditional list in SDXS. We have changed little bit. So I'll show you that only. But try to understand this flow. The map request goes to control plane, or I would say map server, map resolver, and map server, map resolver has forward that map request to the specific fabric edge to get the specific RLOC, because we have this pool /16 pool behind this 2 RLOC address space. So once it has the map request, and in that map request, it shows the IP address that, okay, 10.2.0.1 is trying to reach to this particular IP address, right? I mean, this host is trying to reach to this particular IP address. So the device fabric edge will respond to the ITR or whatever the router is requesting for. That please find the IP address. Behind that, the endpoint has connected. The map
Question.
response. Yeah.
Sorry to disturb again.
No.
You have two ETR over here at the bottom,
Correct.
2.1.1 and 2.1.2.1.
Yeah.
Both of them is going to send a reply.
Correct.
But routing happens only to one particular IP. It cannot happen to both, right?
Absolutely.
Which one is going to reply to that?
So yeah, wherever the exact prefix match has fault, like from where, because this is the shared network, right? You can see. So this particular device has connected to either this particular gateway or this particular gateway.
Okay.
So based on the traffic flow, based on the gateway, it will give the information. But this is the high level. I'm just showing how the response and reply would be going.
Understand. Now ETR can be active standby or active both.
In what sense?
in real scenario sense, can I configure ETR to be active, or active standby, so that if one fails, the other one takes care of it? Because I cannot route a traffic to two different
Yes.
RLOC,
Yes,
right?
correct. So if you have one switch and
Uh-huh.
this particular endpoint has the virtual IP as a default gateway, right? And
Okay.
this two switch is connected as the HSRP or VRRP, then definitely it will forward the ECMP packet, equal cost multipath packets, to the specific control plane, and your traffic will forward. But suppose most of the time in production network, what happens, we don't use this high availability for the fabric edge, because fabric edge has the specific capability, because each and every fabric edge has different RLOC IP address, right? So when, if you are configuring the HSRP between two fabric edge, then the RLOC address would remain the same. So there is no point of mobility. So when your user is moving from one switch to other switch, you don't know anything. So you should consider that switch as a single switch, or you can configure that switch as a stack. In stack, if you have that stacking configuration, you can do it. So some of the critical user, if you want to have that type of availability or that type of requirement, you can put those two switches in stack, and that stack will work as a single fabric edge node. It will
So
not work as a
basically,
two. Yeah,
I'm sorry. Basically, these are normal Cisco switches which are configured to this particular infrastructure.
correct.
I'm sorry. I'm asking these questions because I missed the first class, but I'll
Okay.
go through that slide again. If you share the recordings, when you share the recordings. But
I
the
already
question,
shared. You can go and you can check. So these switches are compatible switches with this SDXS fabric,
okay,
and it has the license, specific license.
understood.
Yeah.
This makes sense. No problem. Thank you so
Yes.
very much.
One more thing. I don't think we have received the drive link.
What?
If you shared this recording of previous class, I don't think I have received it.
So you can check with Networkers Home team, because I have shared already with Sanhita and the folks.
Is it Google Drive link, or like which is shared by LMS?
Yeah, Google Drive link. You're right.
Okay.
Okay, thank you very much. We'll check with them. Thank you.
Sure. And this IP addressing here, if you are seeing, that is just to make you aware, but don't take it, consider this exactly, because this is the flow I want to show you. It could be
Understood.
different, right? Yeah. And you don't see any of the endpoint is having this type of IP address. This is the entire subnet.
Correct.
That's why we have this 2 ETR.
Correct. Thanks.
Otherwise, any endpoint should have /32 IP address only. Never ever /31 or never ever /30, or you may not find any of the endpoints is having less than /32 IP address, right? So it is always single IP per endpoint, and that endpoint will be categorized and identified behind which it has connected to. So based on the RLOC, it will identify.
This is Krishna. One more question. When you're assigning the IP address, that is ETR, to 111 and 2121. So basically, in normal scenario, what we'll do, .1 and .2. But here, third octet has been changed. Any specific reason on it?
No. This is just for example purpose. So whenever I have created this slide, the third octet has changed, right? So there is no specific thing or logic behind it, but yeah, you can consider in that way, because most of the time what happens, this particular RLOC space, right? This cloud where the loopback reachability should be a part of the same subnet most of the time in real deployment, but you can change it as per your convenience, as per your IP addressing schema. But the main ask is like you should have the reachability end to end, from this device loopback to this device loopback, this device loopback to this device loopback. Likewise, for every fabric edge or border or control plane should have the reachability between each other via loopback 0.
Okay, which protocol you're using for reachability?
For reachability, you need to use ISIS if you are going with the LAN automation. If you don't want to do LAN automation and provision your fabric via DNAM, or you want to do suppose manual configuration by your own, then you can use OSPF. But
Okay,
for
but
all,
ISIS is recommended.
yeah, ISIS is the Cisco standard best practice recommendation when you are doing the LAN automation and provisioning of the fabric for reachability purpose, right?
Okay.
So here the same traffic flow, but in different context. But try to look here. The step one, this particular entry, TNS entry, or this particular user wants to reach to this IP address. It will try on step two. You can see 10.1.0.1. Its own IP address is 0.1. It wants to go to this 10.2. On third, it will try to register the mapping entry to the control plane. Here it is mentioning the specific IP, that 10.2.0.1. It will try to identify first, because registration has already been done. It will try to identify the destination prefix behind which RLOC it has connected. So in location set, it has the entry 2.1.1.1. Right now, my ITR is trying to create the tunnel to this ETR based on the response, like 2.1.1.1. Tunnel has created. On fifth state, it will decapsulate the packet, and then it will find the original IP. Original IP header is 10.1.1.1. Here it is mentioned, right? 10.1.0.1. And it will forward the traffic. Got it? Quite simple. It is 5-step workflow.
Sorry to interrupt you.
Yeah.
So here it is not referred mapping system.
So registration has already been done. So that is the kind of traffic flow, data traffic flow I want to show you.
Okay.
Right. So initially the registration is already been done by all the fabric edge.
Okay.
That
Okay.
is
After contacting the mapping system, this is the flow.
Correct.
Okay.
Now forwarding the traffic outside to the fabric edge or outside the fabric edge. So same here, trying to reach host A, trying to reach to 10.2.0.1. It will forward that traffic to the fabric edge. Fabric will do the encapsulation. So the new IP header would be its own IP address, like RLOC address 192.3.0.1. It will try to reach to this mapping server to identify behind which fabric edge node it has this IP connected. It will forward that to this IP address 2.1.2.1, 2.1.2.1, right? So the RLOC address you can see 4.4.4.4, right? And here 2.1.2.1. So the one header has already been appended. So first header is 4.4.4.4, 2.1.2.1. Under that, I have my original header. So 192.3.0.1, and the original ask for the IP address 10.2.0.1. So 192.3.0.1 is the IP address of this particular device, right? It has gone to this particular fabric edge. On this fabric edge, it will do the decapsulation. So it will remove the top header 4.4 header, and the original header it will forward to the destination. So that was the kind of flow for the LISP perspective mostly. So I hope you understood the flow. It is quite easy. Now consider this scenario. This is the again same scenario. I have just created a couple of slides to make you aware about the flow and all. But yeah, this is again the same scenario. Behind fabric H1, I have this IP address. You can see the RLOC address, right? The control plane node IP address. Again, you can see the RLOC of control plane is loopback 0. Here as a loopback 0. Same like that, right? So whatever we discussed, the same thing here. So my traffic is going for this particular PC. So endpoint 1 wants to communicate to endpoint 2. So it is going to this IP address. This this fabric edge will try to reach to this control plane node. On control plane node, I have the simple host tracking entry, like this 10.1.1.12 is connected behind this RLOC 10.0.0.2, right? 10.0.0.2. That is the RLOC of this fabric edge. Here you can see. And then the communication will forward based on the query. So we are good with this control plane. Now it's around 12. So guys, let's have 5 minutes of break. Then we can start with this data plane overview and then policy plane. And on last, I will show you the integration between ICE and DNAC, right? So the same thing, we will use the packet flow, header, and everything in VXLAN and data flow and policy flow, right? So let's meet after 5 minutes. So it's around 12:01. Let's meet around 12:05. Sorry for that. So yeah, so I was talking about these two headers. So the initial part is the same for both the headers, like LISP as well as VXLAN, the outer header. The key difference between these two headers is like here we are using the virtual network identifier, which means your VRF information. And here there is no specific option of SGT related thing. Same like that, here there is no specific option of SGT, but in VXLAN we have tweaked the header and we are using the specific group policy object header where it carries the SGT related information in the VRF. In in LISP, here we have instance ID. So in the initial discussion, you may find that instance ID refers to the VLAN ID and VLAN ID refers to the VNID. VNID refers to the VRF number, right? So both has the same identical header, but the SGT related information is not carrying in LISP, and LISP header can't be modified. That's why on VXLAN, the specific GPO header has been used in SDXs. So as I told, that GPO header for VXLAN, so what key difference it has, you can see here, you can see the key difference is this SGT, segment ID. Previously, VNID was there, the segment ID was not there, and the flag was there, right? So it carries the 64,000 something possible scalable group inside it. The size of that is 8 byte entire header. The UDP header is 8 byte and 14 bytes of your this header, layer 2 header, and 20 bytes of your IP header. That's why we require jumbo MTU frame in SPXS fabric, because all the times it do encapsulation and decapsulation with this frame and this level of data it carries, right? So if any of the device within your fabric does not cater to support 9100 MTU, then your fabric may get failed, your data traffic may get broken. So that is the one consideration before you think for the SDX. Now, when we talk about the scalable group tag and VNI, so you can see the group tag is group policy ID, which is 50. You may not find here the contractor or guest or HR or whatever, but here each name has the specific number tagged to it, and that number is the value you may find in the header when you capture the packet, right? And each VRF has the specific VNID, which is the 4098. That is the VRF number, right? So you don't find any specific name over here, like employee or like your campus infra VN or your guest VN. You may not find that type of name, but the specific number. Now, how the traffic flow would look like. So as I told, this is just the encapsulation and decapsulation, nothing more than that. So on edge 1, your packet is going, it has all the information. Where is my RLOC? Where is my endpoint has connected? So it will try to create the VXLAN tunnel from edge node 1 to edge node 2. So in that VXLAN, it will first classify the specific VNID and scalable group tags. So how it does, like whenever any user gets connected, based on its credential, it has the specific authorization policy in ICE. Based on the authorization policy, that user has given some tag. Like when I say contractor, so some tag has given to that user based on the credential which that user is entered for the authentication, right? And based on the user type, it has the specific VM which is associated. So by default, within two VRF, we can't, with these two different VRF, we can't communicate, right? But within the same VRF, if we want to stop the communication, we want to enforce any sort of access deny rule. So previously we were using based on the IP address, but here in SDXS, we are using based on the scalable group tags. So, the classification, so it could be the static or it could be the dynamic. Most of the time customer is using the dynamic, but some of the endpoints which are not, which does not have the facility to add the credentials, suppose any of the IoT sensor or some of your badge readers. So manual configuration, manual SGT assignment can be done on the fabric edge itself. And based on that, it put the data in the VXLAN header. When it encapsulates the traffic from one fabric edge node to other fabric edge node, it will put the information that my VNID is this, my SGT is this. Now, VXLAN will propagate this contextual information. So, the propagation can be done with this context across the network. So traffic is going to this fabric edge node, and it carries all the information related to this endpoint behind this fabric edge it has connected, right? It carries that information. Now here, this fabric edge node will do the decapsulation. Once it comes to this header, it will identify that, okay, VNID is this. So suppose guys, can you please put yourself on mute if you don't mind? Okay. So whenever this packet comes here, it will do the decap, and on decap, it will identify that VM and SGT. So the first criteria is VM to match, right? So if both endpoints are in same VM, then it will further check to the SGT. So here, suppose SGT value 10 is mentioned for the user, and on this particular fabric edge node, it downloads all the policy from the ICE that 10 is allowed to 20 or not. Suppose this user is connected, and based on its authentication, it has the SGT value 20. So there should be some rule, right? That 10 is allowed to 20 or not. If there is specific rule, then it will follow that rule, and based on that, it will again process another header and forward the traffic if the traffic is allowed between two scalable group, right? If it is not allowed, then my traffic gets dropped here. So always remember, whenever the traffic goes from any fabric edge 1 to fabric edge 2, your policy will be in place on the destination side, never on the source side, because all the policy related decision will be taken care at the destination side. So here the enforcement, the group-based policy will be come into the picture and check the exact thing. But on high level, you understood the data plane traffic has the VXLAN, and in VXLAN there is a specific field which carry the VNID and SGT ID, which will be used to propagate that information from one fabric edge node to another fabric edge node. Now, this is really interesting topic to understand for ARP traffic, specifically in the SDXS. So you can see I have one host which is connected in VRF1. I have host 2 which is also connected to the VRF1, but the fabric edge would be 2. And host 1 and host 2 belong to the same subnet. That is the assumption, right? Now, both has the entry to the control plane node. So after initial connection, both fabric edge will register these two hosts to the control plane and the location of the control fabric edge node, or R loc, I would say. Now, host 1 wants to communicate to host 2 since they both are in the same subnet. So first it will send the ARP request for the MAC address of host 2 because initially we don't know the MAC address of the second endpoint, right? So without ARP, we can't proceed the further. So it will forward the ARP request to the Fabric Edge. Fabric Edge give its own gateway as a proxy ARP response. It will give the Anycast gateway, whatever the gateway it has for this VRF, it will provide that gateway and it will forward the ARP information in its ARP header, right? So my source IP would be H1 IP, destination IP would be the H2 IP, source MAC would be H1 MAC, destination MAC would be the Anycast gateway MAC, which is the Fabric Edge 1 Anycast gateway MAC as a gateway, right? Now it will request to the control plane. So Fabric Edge will request to the control plane that, hey, I want to reach to this host. Where should I go? Here's the entry to Fabric Edge 2, right? It gives the response that if you want to reach to host 2, please go to the edge 2. So that is the map response or map reply with the location information. Once it has the information, you can see it has the information like all the information related to the VN, like virtual ID. VN ID means the VRF instance ID, right? And you can see the encapsulation here. So inner packet would be this. Your source IP would be H1. Destination would be H2. The original header is that. Outer header is this. That is the encapsulated header. The source IP would be the Fabric Edge 1 IP address. That means the loopback 0 IP address of Fabric Edge node 1. Source MAC would be the router MAC, means this particular Fabric Edge node 1 MAC address. The same thing, the destination IP of Fabric Edge 2 and next of MAC will be the intermediate node. Suppose if we have any of the intermediate node, those intermediate nodes would be useful to forward the traffic. So they will not be part of Fabric. That will not do any sort of encapsulation or anything, but they just forward the traffic from one Fabric Edge to the other Fabric Edge in case if we have large Fabric site. Otherwise, it will create the direct point-to-point connection and the traffic, the tunnel has encapsulated from FE1 to FE2. Once my traffic reach to Fabric Edge 2, it will decapsulate the VXLAN based on the routing lookup, based on the access policy, whatever it finds in the VXLAN header, it will either permit or deny the traffic, and it will forward the traffic to host 2 in case if the access policy is permit for this host to this host communication. So that was kind of detailed information on the data plane side, right? Now let's talk about the policy plane. And in case if you have any question on data plane, feel free to ask me before proceeding with this policy plane. Quite
Transport
simple, right?
itself, it is simple, but the transport itself is through TCP or UDP.
So, you know, right, previously we discussed that VXLAN header, and in VXLAN header, we have seen the VXLAN works on UDP. So that is the header. If you can look here, let me go back. Where is this slide? 1 sec.
But when you're encapsulating UDP, is it going to happen through TLS or DTLS?
No, VXLAN has this separate header, right? You can see this header. My source, the outer MAC is this. My outer IP address is this. Then UDP header is this. Then VXLAN header is this. So it is encapsulated inside UDP. So why SSL or any other?
Okay, understood. Okay, thanks.
Okay, so let's start with this policy plane, and it is based on this Cisco TrustSec architecture. So here you can see we have this TrustSec. So traditionally in core access and distribution layer, core distribution and access layer, we are trying to segregate users based on different VLAN or VRF, right? Like employee, voice, supplier, bring your own device VLAN, or quarantine VLAN, right? And based on that, we are trying to create the permit deny rule, that this IP is allowed to this IP, this protocol with this protocol or not, this particular user is allowed to use YouTube or not, whatever, right? So here you can see the list of the access list, which we generally configure. And by default, all the traffic goes to the headquarter. In headquarter, we have expensive security stuff, firewall, IPS, IDS, everything. And on that data center, we are trying to check the traffic, whether this user is eligible to access that data or not. So that was a typical complex network infra. But here in SPXS, we try to simplify it with the help of Cisco Trust Set. And the key part is like SGT and BN, which we generally discussed when we talk about that use case. So as I told you in initial side, so classification is really important, because based on the classification itself, you can assign the correct identity to correct user, right? So it could be static or it could be the dynamic. Now, propagation. So it is also important, because whenever I'm forwarding my traffic to some remote end, so on remote side, it should have some context information that, okay, this traffic is coming with this VRF information, and this traffic is initiated by this identity, right? This user. So that context needs to be propagated. And the last step would be the enforcement. So based on the access, we have the enforcement policy, whether this traffic is allowed or not. Now, when we talk about the static access list, it is quite traditional, and it is really difficult to identify for the specific endpoints. If we talk about the current demand and current network growing, the users are getting onboarded on our network is quite high, with their own BYOD devices, with own applications and customized applications. And we cannot implement security with this kind of traditional architecture nowadays. And it would be quite costly and quite complex in terms of maintenance, right? So to avoid and to resolve that issue, we have created this integration, and Cisco TrustSec is in the market from quite long time. But the actual benefit of that we are using when we integrate that with Cisco DNA Center, Cisco ICE to Cisco DNA Center. So you can see we have employee, supplier, and other device, which is not compliant, or I would say guest user, right? I have that all the user in VLAN B, that means VRF B, and I have voice data in VLAN A, that means VRF A. Now, based on their authentication, that user gets tagged, and that tag will be used for authentication for this access control, right? So you can see on this slide, we have employee is permitted to employee. So communication between these two is done, but employee to supplier, the communication is negative. Employee to app server, the communication is okay, but employee to non-compliant user or guest user or contractor, this is not permit, right? So that's how you can create the policy, and based on that, traffic will flow. Now, suppose if my employee is moving from one side to other side, it will again check that policy itself, that for this employee, the servers are not accessible or not compliant or what. So if I put this employ a non-compliant user in the same VRF, then also my communication is denied. You can see employee to this non-compliant is denied, and this particular employee to this non-compliant user, like shared services to this non-compliant. So likewise, you can create any sort of segmentation and access permit deny combination. Within URF, you can deny, and different VRF, that is by default denied, right? Unless and until you do the route linking. So ICE has different type of flavors and personas, and what are the key component in ICE which would be used, and why ICE is the integral part. Because whatever we are doing on the DNA Center. So what is the role of ICE? Which persona did this access control? Which persona would be used for integration and all? We'll see in upcoming slides. But here the classification and other thing is mentioned, like some of the devices are getting whitelisted based on the shared secret. Whenever initially you have your network devices, your routers, switches, everything, it is getting whitelisted in ICE. That's based on that, it will start communicating, or it start establishing the reachability of their loopback to loopback communication. So we are good with those network devices because it got already whitelisted on ICE. You can upload that device entry manually, or you can do with via CSV file. You can create a kind of Excel where all of your fabric edge node or fabric border device or control plane, you can list down on Excel sheet, and you can upload on the ICE to make it whitelisted. And same like that, for any traffic, you can have that type of scalable group access list, and you can create any sort of contract. So everything, whatever you do in terms of policy and segmentation, even like whenever you are creating SGT or whenever you are creating virtual network, you don't need to go on ICE. You just need to log into DNA Center, and on DNA Center, you need to do it. Then the communication between DNAC and ICE would be done via PX grid persona. How it is done, I just give you the high level overview on that, but we'll see the detailed persona information. And based on the authentication, here you can see the device gets authenticated and gets assigned the SGT. So whatever we have discussed, that is the same, right? Different types of authentication we will see. So same thing, whatever we have discussed. So initially, whenever the user gets connected and the fabric edge has the information for the far end device, the RLOC information, it will try to create the VXLAN tunnel. Inside VXLAN tunnel, we have the information of virtual network and SGT of the endpoint 1. On the destination side, it will try to first match the contract that this particular endpoint 1 is permittable to communicate this endpoint 2 or not, right? And based on that, it will forward the traffic. So the classification is really important, and the general way of classification is dynamic, because based on the supplicant setting on the laptop or any of the device, user needs to add its own credential, right? And based on the credential, whatever the policy you have created on ICE, or suppose you don't have any sort of AAA related or radius related configuration on ICE, but you have some sort of Microsoft AD integration with ICE, right? Then also you can get that type of authentication through ICE, and ICE will approve if the credentials are correct. Once credentials are correct, that is the kind of authentication part done. The authorization part still pending. So based on the authentication, you can create any sort of policy that, okay, if this user comes, I will put that user in employee virtual network, and I will assign that user to the tag 10. So that type of authorization policy you can create. That is part one. Now, other device like your IP phone or your conference WebEx consoles, it has the MAB authentication, which is the MAC authentication bypass. So based on the MAC address, it will try to authenticate and it will provide the authorization policy. Same with the guest, web authentication template gets downloaded on the user and on the guest portal. Once the guest entered its name and mobile number, generally it gets this specific access. Like generally you have seen on the airports where guest portal comes and web authentication also works. Other than that, you can do the classification statically, but the static classification is completely manual. You need to go hop by hop basis and do the classification. So this is how you can do, like on the VLAN to SGT, subnet to SGT, layer 3 interface to SGT, layer 2 port to the SGT, or any specific virtual machine if you have, you can give the SGT to that machine as well. So this is how, there are so many flavors, but yeah, on slide I can show you this only. Now, what is the configuration when you are talking about the static configuration, right? So there is a specific command you need to enable on the switch, like PTS, role-based, SGT map. So this IP address has this particular tag. So you can give the IP address to tag mapping, IP to tag, right? So whenever any user comes, and once that user goes with authentication process, and once that user gets this IP address, it will also get assigned to SGT 80. So this is a manual configuration, but it is not recommended because the configuration would be too much for any user to do. But some of the financial banks or some of the customers are using with that part as well. So depend on design. So you can do any sort of allow or deny type of contract, right? So here you can see the normal IP access list has created the permit IP TCP destination 80, that means your HTTP and HTTPS, and permit ping. So only 3 protocol has allowed, rest everything gets denied. Now, how to use that particular access list? You can see this is the command CTS role-based permission from 20 to 70. That means the group tag 20 to 70 use this access list. So there is no need of IP address to put or anything like that, right? Just group they have added, and they use this scalable group access list. So quite simple. And this is unidirectional. So suppose from 20 to 70, this access contract will work. But whenever 70 to 20 traffic comes, everything will remain the same, like normal. If you want to deny or block this from 70 to 20, then you need to apply from that as well, like from 70 to 20, and use this access list. This is unidirectional. On DNA Center, it is quite easy. You just need to go on the policy page under policy administration. You just click to the group-based access control, create add policy, right? You can create any of the contracts. So you can see the policy name is new, description, whatever suits you. You can create permit or deny contract. And you can also add the scalable group. So on the left-hand side, you have a couple of scalable group tags like this. You can just drag and drop based on the scalable group source and destination. And you can just create the policy. Quite easy, right?
Yes, sir.
Cool. Now, the integration is really important between your Cisco ICE and your DNA Center. So your ICE has so many capabilities, and initially will be acting as a triple for your endpoints. And once this particular part, once you do the integration, it will also use as an authorization as well. So whatever the policy you create, that policy will be used for the authorization purpose, right? And as I told you, like your routers, your network devices, initially, or everything gets whitelisted inside the fabric based on the shared secret in the certification. Now, let's talk about different personas of ICE. So you can deploy ICE in different way, like standalone deployment or distributed way of ICE deployment. So based on the design and the scale, you can use your distributed ICE architecture or standalone ICE architecture. If customer is big and customer is having so many fabric sites, then you should go with the distributed way of deploying ICE. Otherwise, standalone one is enough. Now, the first persona is PAN, which is your policy administration node. So what is the use of that? So it will, whatever the policy you are creating, the policy has been configured on the policy administration node. Like any certification creation or any sort of database, it has been created on the PAN, policy administration node. Now, there is another important two personas, which is your PSN and MN2. So PSN is your policy service node. So any of the AAA related requests comes on the policy service node, and monitoring and troubleshooting node, MNT, it gets all the log related information, all the contextual or I would say log related information gets saved on the MNT node. So if you have one ICE box, you can have all the personas within it. And if you are using with large deployment, then you can segregate different ICE to different personas. Like this dedicated ICE is acting as a PAN, this dedicated ICE acting as a PSN likewise. But for standalone, it will be all in one. And for secondary administration node, so the first one is primary administration node. The second one is a secondary administration node. So in distributed deployment, you are going with that type of scenario. In case of PAN goes down, your secondary administration node will take over and acting as a PAN. And the fourth or fifth, I would say, which is your PX grid, that exchange the contextual information. So to the other party, other platform, that's acting as a platform of ICE. So whenever you want to integrate this particular ICE to DNAC, all the contextual information is getting published on DNA Center via ICE through this particular node, PX grid, right? That's why we generally called the ICE DNAC integration as a PX grid integration. But whenever you are installing or integrating your DNA Center to ICE, you just need to mention your policy administration node IP address, PAN IP address, because that is the master persona. So what are the prerequisites? It's quite simple. You can just go with this flow. So version should be compatible. It should have the SSH enabled on port 22. Credentials should be same for ICE, CLI, and GUI with super admin right. Our PX grid should be enabled, and ERS should be enabled. So ERS is the one setting in administration under ICE that can be used to make any sort of change inside ICE. So whatever you do, like suppose you have created any sort of policy on DNA Center to between two identity containers, right? Between two endpoints, suppose that policy is getting right on the ICE, and ICE will then finally push that policy to the fabric edge nodes. So DNA Center will not push any sort of information on fabric edge node, but you need to do all the things on DNA Center, right? Creation of policy, everything. That policy getting right on ICE, ICE will actually propagate that policy to the fabric edge. That is the flow. The process flow is like that. On DNA Center, you need to give the IP address of your PAN, all the credentials, which we generally discussed, like super admin credential. Once you enter that, FQDN as well, and once you enter this credential, your DNA Center will try to create the SSH connection to the ICE on port 22, right? And once that connection is established, it will try to exchange the certificate. So by default, both the device has the certificate installed in its own. And after certificate exchange, trust and establishment happens, and they create the PX Grid subscription. So in Cisco ICE, you have an option of PX Grid dashboard where you can see the DNS Center request and the subscription request, I would say. And by default, nowadays, with this new version of ICE, it is getting approved by default, but initially you need to do it manually. You need to go to ICE and you need to approve that subscription request from DNAC. And then once you do, or once that automatically done, all the trust check related metadata and sessions getting downloaded on DNS Center. So by default, whatever the information ICE has, it is getting downloaded. And then whatever you create, like any policy creation, any configuration on policy, that getting pushed with the help of ERS, that is RESTful API to ICE, and then it will push to the network devices. So quite simple. This is the flow, very normal. So this is the kind of workflow, like any of the device, your phone, your CCTV camera, your employee getting first getting authenticate itself, or suppose based on the MAC address, the device getting authenticated. After that, ICE will put that device or ICE will send that information that this particular employee comes, then please assign this VN and please assign this SGT. If any contractor comes, please assign SGT 20 and the VN is different, right? And if any IoT device comes, then you can assign the SGT 30. By default, if you want to have single VN or very limited VN, then also it's fine, right? But based on design, it is based on the customer design. You can have the VN and segregation like macro and micro segmentation. And that is the policy it is getting created. Now that policy has been exchanged via PX Grid through context. And whenever any authentication happens, the MNT node also share the context to the PX Grid. The PX Grid has the integration with PAN, and PAN has the connection to the DNS Center, right? So all the information will be reflected on the DNS Center. DNS Center, you can create the policy that 10 to 20 is denied or approved. So by default, that permission, whatever the permission is there, it will be reflected on DNS Center via this flow. Okay, so we are good with this section, I guess. I hope you enjoyed and understood some of the components related talk on SDXS. So far we have covered this particular section 1, 2, and 3. Tomorrow we are going to discuss wireless architecture. And for these two, the DNAC walkthrough is pending. So whenever lab is available, I can show the basic walkthrough, how you can create some of the things and what are the importance of that. Apart from that, like tomorrow, just one announcement is that kindly note, as I'm traveling outside India, so I'll be on airport tomorrow, but I'm not sure when I can get some time to deliver the session. So you can keep in mind that tomorrow's session would be around 1 p.m., right? 1 p.m. IST. So I'll try to finish as much as on the wireless architecture. But in case if I get some time earlier, then I can again reach out to Networkers on team and they can schedule it. So you can be consider that 12 to 1 we can start this session, suppose. Mostly on 12, but if 12 is not available, then 1 p.m. So 1 we can start, and 2 hours of session, and we'll finish this wireless article. Okay.